should be able to explain force in equilibrium. You should be able to sketch a triangle of force in equilibrium, and also we should be able to solve problem involving force in equilibrium. Okay, so what is the definition of equilibrium of force or force in equilibrium? So if the forces that act on an object is in equilibrium, it will produce zero resultant force. Okay, we will get zero resultant force. For example, this vase on a table, it is not moving, so it is in force equilibrium. Okay, or this lamp, okay, hung between two strings. Okay, so this is also force in equilibrium. How do we know that the force are in equilibrium? When the object is either not moving or moving with constant velocity. Okay, so previously we have looked at force in equilibrium that is parallel to each other. Okay, for example, an object on a table that is not moving, okay, or an object moving with constant speed. So we have discussed this. But what if the forces that is acted to an object is at a certain angle? Okay, so as you can see here, we have a lamp and we have two ropes that's holding the lamp, and the lamp is stationary. So from here, the system is in force equilibrium. Okay, so how are we going to calculate if we need to calculate the of the rope, let's say rope T or rope P? Okay, so there are methods to sorry, method that we can use to calculate whether the tension of P or the tension of T or even the weight of the object by using triangle or free body diagram or triangle of force. So this one is triangle of force drawn to show equilibrium of three forces acting on an object. So magnitude of the three forces are represented by the length of the side. So actually the method is the same as when we need to calculate the resultant force. Okay, untuk resultant force dan juga untuk force in equilibrium, when the force is at a certain angle, the method is the same. Okay. Okay, so what is the difference? Before we continue with the discussion here, let's look at what are the difference between resultant force when a system has a resultant force, and when the system has force equilibrium. Okay, so let's say we have an inclined plane. Okay, this one is also an inclined plane. So an object on the inclined plane. So we have a force downward, which is the weight. Okay, and this weight can be resolved into two components. One perpendicular to the inclined plane, the other one horizontally or parallel to the inclined plane. This one also the same. Okay, so let's say we have let's say there is no friction for diagram A, but there is a friction for diagram B, FR. So here we label it as Fx. Okay. So from these two diagrams, let's say Fr is equal to Fx. So we know that this is in equilibrium, whereas for A, the system is not in equilibrium. When we calculate, we will get a resultant force. So when we draw a triangle force for these two systems, the difference between A and B is the direction of force, or the direction of the three forces. Okay, so let's draw W and Fx. Nanti sekejap. Yang ini tak sesuai untuk saya bagi contoh. Sorry. Kita bagi yang lain yang lebih senang sikit. Let's say we have an object and it is being pulled by two forces. Okay, so there is no other forces acting on the object. Okay, only these two forces. Let's say this is T, this is P. So in order for us to determine the resultant force, we can use parallelogram or we can use the triangle of force. Okay, if it's the triangle of force, we draw the T, the force T, okay, and shift it here with the same magnitude, with the same direction. Okay, so look at the direction of the forces. Okay, the direction of the forces, dia kalau awak lukis yang merah ni dengan yang purple ni, dia akan macam satu flow. And then the resultant force is from the initial point to the final, macam ni. Okay, nampak tak? This is when the system have resultant force. Kita ada satu force yang biru tu, yang merah tu dengan yang biru tu, and the direction dia macam satu menuju kepada satu arah lah. So that is the resultant force. However, let's say we have an object yang sama, different object lah. Okay, we have T, we have P, but at the same time there is another force downward, which is the weight. So we have three forces, and all this and these three forces is in equilibrium. Okay, so bila kita nak draw triangle force, kita ambil P here, okay, and then yang this is P, sekejap, okay, this is P, and then we draw okay, we draw W. Sekejap, kenapa saya punya ni tak equilibrium? And then we draw, this is P, and then we draw T. Okay, P kalau awak tengok dia parallel to P, and then dia parallel to T, and then this is the weight. Okay, can you differentiate between these two diagrams? Kalau dia ada resultant force, arrow dia akan menuju kepada satu arah. But if the force is in equilibrium, dia punya arrow dia akan jadi satu cycle. Okay, so the difference between the triangle force untuk resultant force and untuk untuk force in equilibrium is the direction. Okay, so kalau resultant force dia akan ada point awal and then ada point akhir seperti menuju ke arah tertentu lah. But if it's in equilibrium, the triangle will be, the direction will be in one cycle. So itu perbezaan dia. Okay. So let's look at the this one. So we have this is from our textbook. Okay, activity 1.6. If you look at the textbook, it is page 19. Okay, page 19. Draw the triangle of force. We are given a stationary box on an inclined plane. Okay, so when the object is stationary, it shows that the object is in force equilibrium. Therefore, the direction of all the three forces in a triangle should be in a circle. So how are we going to draw? Kita akan draw one parallel to R, and then F, we draw parallel to F, R, and this would be the W. Okay, boleh follow tak? Boleh ikut tak? What is the difference between triangle force for resultant and the difference between a triangle force with resultant and the triangle force for force in equilibrium? Okay, kalau force in equilibrium, bila awak draw the triangle, the arrow is in circular motion lah, macam nampak dia pusing. Dia tak ada final destination. Okay, but if the system is in a resultant force, dia akan direction of force tu dia akan follow. Okay, so mungkin awak kata saya draw ni sebab saya dah tahu. Okay, tak juga. Okay, let's say we draw, ambil ni, pindah kat sini, and then this is W. So FR, R. Okay, you get the same cycle untuk triangle. Boleh? And we can use a parallelogram technique to get the force yang kita tak tahu value-nya. Okay, so sama juga, we use scale, we follow the angle for the triangle, and we will get which force that we don't know the value of. Okay, so let's look at the B, photo and frame. Okay, we have two T's and then one W. Two T's is the tension of the string, and the angle of the strings are the same. Okay, so same like before, we draw a force that is parallel to T, and then tinggi sangat, kejap. Okay, force parallel to T, and then the other T is this way kan? Okay, so this is the weight W. Okay, nampak tak? How we draw triangle force untuk force in equilibrium. Okay, so the last one, ship with uniform velocity. Yes, wait, any question? Yeah.
Where do we put the angle?
For this one, we need to follow the angle. Okay, tapi yang ni sebab saya lukis freehand, I sketch saja, so I did not measure the angle lah. But if you you need to draw, you need to measure, let's say the W using the drawing method, then you need to measure the angle accurately. Okay, same method you use for calculating resultant force. So for example, kita dah tahu T, the two T's kita tahu tapi kita tak tahu W. Okay, there are two methods actually. One is using calculation, the other one is using the drawing of the triangle force or parallelogram. Okay, any question? Any more question on this?
How we know where's the position of the A if they didn't mention the angle?
Okay, how do we know the position of our forces? Yeah.
Hai, Assalamualaikum semua.
Kenapa?
Saya Datuk Ikram. Pada hari ini,
Sorry.
saya cerita mengenai BM.
Okay, so how do we know how to draw which to which? Okay, so this system, photo frame is hung by a string. So kalau photo frame is hung, maksudnya it is not moving, it is stationary. So kalau stationary, the direction of the forces mesti dalam satu circle. Okay, itu satu. And then kita draw, I don't know, example B. Okay, so kita ulang semula example B. So this is the drawing of B. It's like this, isn't it? Okay, if I draw the forces without the frame, this is the three forces, betul? Okay, so we are to draw, dia kata dekat sini, sketch triangle of forces for the situation. So dia suruh sketch saja. But if dia suruh calculate, let's say calculate W, then you have to draw the diagram, follow standard scale, and also you need to measure the angle accurately. Okay, tapi yang ni dia kata sketch sahaja. So to sketch the triangle force, we can move the forces anywhere, kan? Except, but there is a condition, which is the direction cannot change, the magnitude cannot change. Okay, so I take this and then I shift it here. Okay, and then I take this one. I use different color. Let's take blue. Okay, this one here. This is T. Okay, and then W, I shift it here. Okay, boleh follow? Well, if you look at my diagram, dia perpendicular, dia parallel, nampak? Dia parallel to each other, dia parallel. Ni dengan ni, merah dengan merah ni parallel. Yang biru dengan yang biru tu pun parallel. W dengan W tu pun parallel. Okay, so I did not change the direction. And I also did not change the length. Tapi yang ni sebab I tak tahu the value, so andai-andaikan sajalah. Dan dia kata pun sketch kan. Okay, so what I did was I just shift the force to make it a triangle. Okay, and if the force is in equilibrium, the direction of all the sides of the triangle should be in a circle ataupun a circular punya motion. Okay, so for B, boleh faham tak? Any question? Okay,
Yeah,
boleh terus?
Don't know
Yeah?
I don't know how to put the angle.
For the angle, kalau kata dia suruh draw kan, so this is the angle kan, theta. So you have to draw the angle according to theta will be here, and this one theta will be here. Nampak? Saya lukis mula. Mana tadi angle tu? Okay. So if we draw with theta, kan ini horizontal line kan? So this is the theta, betul? Theta ke? Alpha, sorry. Alpha. So this one is the alpha also. Okay, so alpha is horizontal to the force. Jadi, how to measure the horizontal to the force? Ini horizontal. So this is alpha. Okay, ini horizontal. So alpha should be here. Okay, so that is how you draw the force with the correct angle. Boleh? So apa yang I buat? Sorry. Is I only shift the force. Shift saja. I did not change anything. I did not change the direction. I did not change the value. I did not change the angle also. Okay. So, but when I shift the position of the force in a certain way that it form a triangle, so we get what is called a triangle force. And by using this, we can measure any force that we don't know. So let's say we have T, but we don't know W. So we can use this method. Or if you don't want to, don't want to use a drawing, you can calculate. Tapi kalau question kata draw, then you calculate, you won't get mark because you are not following the instruction of the question. Okay, question boleh minta apa-apa pun. Dia boleh minta you draw, dia boleh minta you, dia just kata what is the value of W, then you can use any method you like. But if this question asks you by using triangle, force of triangle, okay, or by using parallelogram, determine the value of W. So then you cannot use calculation. You need to use the drawing method. Okay, boleh? Any more question on example B? Yeah.
If you know the angle for the alpha for in the circle that you draw, then what is the angle opposite side? Is it 90 degree minus alpha?
Opposite side, which one? Is this one? The line that I draw to?
No, the other side.
The other side,
Side of triangle.
this one. This one you don't have to calculate because it is not in the triangle.
Inside the triangle.
Oh, inside, yes, it would be 90 degree minus alpha.
It must be 90 degree.
Yes,
The
90 degree. Yeah.
The alpha plus the angle inside the triangle must be 90 degree.
The alpha plus inside the triangle. This one. Is it the one that I'm drawing here? I label as apa, beta? Alpha and beta should be 90 degree. Yes. How do I know that alpha and beta should be 90 degree? If you refer to the diagram, okay, W is here. Kalau I pindahkan lah. Okay, if I shift the W, so W is here. W is 90 degree to the frame. And in this diagram, W is this one kan? So it is 90 degree with the horizontal line. So alpha and beta should get 90 degree. Boleh tak? For this one, actually, what I did was I only pindahkan saja. I did not change the direction. If we did not change the direction, the angle should be the same. Okay, so ini alpha and this is beta. Ni W kan? This is W. And let's say I draw T. Yang ini. Panjang kan? T ni. You will get the more or less the same diagram. Kan? Yang this one and this one. Okay, saya padam balik and then I'll draw again so that you can see more clearly. Okay. So let's draw this one. I draw on the diagram itself so that you can see. So this one is T I tak usik yang memang ada, and this one I panjangkan, which is I pindahkan here, and this is the W. Okay, if you look at this diagram, with the diagram that I've drawn previously, it's the same. Cuma dia sangat-sangat lah sebab I use freehand kan. Kalau I guna protractor, I guna pembaris, I will get betul-betul punya ni. Yang ni should be like this. Okay, so yang tadi Wen tanya, angle ini dengan angle ini, kan? Should get 90 degree. Yes, it should get 90 degree because W is perpendicular to the frame. Okay? Boleh?
Boleh.
Faham
Faham.
Yes. Okay. Any more question on A and B?
Teacher.
Post triangle tak ada So we go to the, yes?
Teacher, how will they ask the question when they want us to draw the triangle using the scale? Like sometimes you can use formula, right, sir? But
Yes.
how will we know that we have to draw using the scale to find the answer?
They will ask. Okay, so look at page mana? Look at page 22 in your textbook. Okay, figure 1.328 show a box of weight 50 Newton stationary on inclined plane. A. Draw a free body diagram of the box showing the weight. Dia minta dia draw. And then B. By drawing a scaled triangle of force diagram. Dia minta in the question. So you have to show your answer in diagram. And then C. By resolving, ni dia minta calculation. So that is why you need to know both method. You need to know the calculation method and also you need to know the drawing method.
Okay, thank you, sir.
Okay. So, any more question on this? Sorry. So let's look at number 3, the third one from activity 1.6. Okay, we have a ship moving with uniform velocity. So uniform velocity is another clue saying that the system is in force equilibrium. Okay, so we are to draw the triangle of force. Sorry. So firstly, I'm going to show this in the diagram itself. So let me draw this T here. Tak nampak. Let me draw this T here. Pun tak nampak juga. Okay. And then look at R. R is this direction. Okay, so if you look at the diagram here, so this is the triangle of force and the direction of forces macam buat satu cycle. So this prove that the forces are in equilibrium. Okay, so sekarang saya draw dekat luar. I draw one force that is parallel to T, the same value as T. Okay, and then I draw this one. Saya draw dekat sini. Okay, and then I draw R because R is horizontal. Yang ni put here. Okay, and then I draw R. R is like this. So this is the triangle of force, and the direction is in a cycle. Okay, boleh nampak tak? Dia lari sikit lah. Yang this one I draw different method. I shift this one to here. Tapi yang ini I shift it here. Kita boleh shift mana-mana. Your answer would be maybe can be different from the others. Okay, it depends on how you shift your triangle, your force. Okay, so I can get like this, macam ni. This is T, this is T. Sorry, this is R, this is T. Sekejap. Like this. Saya boleh dapat macam ni, saya boleh dapat macam ni. Answer will be different with orang lain. Depends on macam mana awak susun. Tapi syarat dia, direction of the force you cannot change. The magnitude of the force you cannot change. And since this is in force equilibrium, the direction inside or for the triangle cycle. Okay, boleh follow?
Teacher, how about
Yes.
the force that is moving with a uniform velocity?
It's uniform velocity is constant, is a force in equilibrium.
Then if it's in force of equilibrium, isn't the R is cancelled by the uniform velocity?
Maybe the force, the object is moving with inertia. Okay, at first, masa memula, force exerted, dia ada perubahan kan. At first, the boat is not moving. And then when force is exerted, the force is not equilibrium. Mesti ada resultant force. Okay, so sekarang ni dia cerita tentang the ship is moving with uniform velocity. So, bila object move in uniform velocity, the object is moving with inertia. Okay, dan dia boleh berada in force equilibrium. Because ini bukan initial situation. Ini situation dia sedang bergerak. Tapi kalau initially, you cannot get force in equilibrium. Sebab initially, the boat is not moving. When force is exerted onto it, dia akan move kan. So there is acceleration. So there will be no way for the system to be in force equilibrium. Tapi after some time, the ship moving with uniform velocity, then that is the part where the force is in equilibrium. Okay, dia punya water resistance dengan the two forces tu dah equal. Pernah dengar terminal velocity of person dropping, free falling from a certain height? That is the same situation as this one. Bila orang mula-mula jatuh, dia akan accelerate. But at a certain point, the acceleration becomes zero. It moves with constant velocity. Why? Because the air friction and the weight are the same. Itu kita panggil sebagai terminal velocity. So it is not impossible. Yes.
In this condition, the uniform velocity we no need to count it in our triangle.
Which one? The uniform velocity you don't have to show. Because the system is in force equilibrium. But if the system is has a resultant force, then your drawing should be like this. Itu beza. Dia ada direction, beza dari segi direction is this one, and this one. Dia macam ada direction towards somewhere kan. Tapi yang ni tak ada. Dia cycle. Because T dengan T ni dengan R ini adalah sudah cancel off each other. Okay? Boleh? Boleh faham tak? Ke atau masih kurang jelas? Ya, Warren?
Kan.
Boleh?
Boleh.
Okay. solving problem involving, this one is calculation. Okay, just now I said that there are two methods. One is calculation, one is drawing. Why do we need to know both? Because it's up to the question. Maybe sometimes the question wants us to answer in drawing, so you need to do drawing, or it can ask the magnitude. Dia tak cakap calculate pun. What is the magnitude? So from there you can choose any method. Tapi kat sini dia mention to calculate, then you need to use calculation. Okay, so this is from example 1 in the textbooks. So we have 3 forces, the 8 Newton, T, which is the tension of string T, and P, the tension of string P, and W, the weight of the object. Okay, and T is exerted at 60 degree horizontally. Okay, so method 1, what we should do is, because this T is making an angle, so we cannot calculate the magnitude of the force directly. So we need to resolve T into component. Yang ni kita dah tahulah sebelum ni. So we can resolve T into 2 components. One is vertical, the other one is horizontal. Okay, by using sine and cos, we can calculate the force. Okay, so is T given? Tension T is 8. So 8 sine 60 and Tx is 8 cos 60. So A, calculate the magnitude of tension P. So P is exerted horizontally. So we have 2 horizontal force, which is P and also component Tx. Okay. So since the object is in equilibrium, so we know that P must equal 8 cos 60 because the object is not moving. Therefore, they are in equilibrium. And when forces are in equilibrium, opposite forces parallelly should be the same. Okay, so P, kira lah berapa? P is 4 Newton. Okay. And then weight of the lamp. Okay, weight of the lamp is this one. It is exerted vertically and we have 2 vertical force, which is the weight and component Ty. Okay, since the force is in equilibrium, once again W equals 8 sine 60. Okay, and W is 6.93 Newton. So that is how they get the answer for page 21, example 1. Okay, so any question on this? And if you look at page 21, they also show the second method, which is the scale drawing for triangle of force. So dia guna, dia tak resolve, dia guna drawing, scale drawing. Okay, so macam mana dia guna scale drawing? Saya draw balik kat sini, ini T, ini P, ini W. Okay. Then this is 60 degree. This is 8. Okay. So, macam tadi, we shift the forces until it form a triangle. Okay, so kita ambil ini P. Okay, and then kita draw again T. So this is W. Okay, and then this angle should be 60. So since T is 8, so awak kena lukis scale diagram. Yang ini guna macam kaedah matematik kan, untuk dapatkan length of W and also to get the length of P. Okay, so gunakan scale yang sesuai, and then since you know the angle of 60, you can calculate W and P using the diagram of the triangle. Okay, so since this method awak untuk lukis triangle tu ada belajar dalam matematik kan, so awak boleh draw berapa W, berapa P. And W and P is 90 degree. Okay, so any question on this? Ini boleh?
Can.
Okay. Then this one is also example. Okay, so you boleh refer on the textbook on page 22. So yang ini dia suruh draw. So it depends on the question. The first one, they ask us to draw a free body diagram. A free body diagram is to draw the forces that acting on the object. The forces ada satu weight. Okay, and then we have friction. Friction is here, FR. And then we have normal. Normal is 90 degree to the surface. This one. Yes. Okay, so this is what we call as free body diagram. Forces yang ada pada object. 3 forces. One is the weight, one is the normal, and the other one is the friction. Okay. And then draw a scale triangle of force. So kena lukis, dia dah bagi pun scale dia 1 cm to 10 Newton. Macam tadilah, macam example 1, the method. Okay, kita mula-mula we need to know which one is where. So we know that R dengan FR is perpendicular. So let's draw R. Okay, let's say this is R and this is FR, and they both are perpendicular, and this is W. Okay, so let's say you don't want to draw like this, nak pindah lain pula. Kenapa saya draw jadi lain? Boleh, you draw here and then ini kita pindah sini. Tak boleh, dia tak jadi cycle. Sekejap. So ini R, ini FR, and then this is W. Also can, provided FR. Sekejap, kenapa saya punya ni tak selari. Saya salah lukis kot. Okay, so it's like this. FR R. Saya salah lukis tadi. Okay, so yang ini dengan ini kena parallel, yang ini dengan ini kena parallel. So orientation tu boleh berubah-ubah lah. Okay, as long as dapat triangle dan direction of the triangle is one cycle. Okay, and angle dia kena betul. Angle yang ini is 90 degree, so yang ini 90 degree kat sini, 90 degree dekat sini. Okay, boleh?
Perempuan sewaktu balik sekolah, perhatian kepada sebuah kuih. 10 minit daripada sekarang kita akan bersurai. Pastikan teacher dan kursi anda semua telah disanitasi. Murid hendaki menutup pintu berjalan secara teratur ke arah pintu pagar kecil iaitu pintu B. Saya bacakan SOP COVID-19. Sentiasa amalkan 3W, wash, wax, on, kerap mencuci tangan dengan air dan sabun atau sanitizer. Pakai
Jadi kita kena kecilkan mic kita. Sebab tadi sebab kecil tu saya main-mainkan benda tu besar kecil kan. Bila saya kecilkan benda tu cikgu hitam. Lepas tu saya besar kan cikgu nampak tak? Oh okey, agaknya benda dia nampak. Maksudnya dia tak cukup space benda tu masuk. Agaknya lah.
Rasanya lah. Sebab dia PowerPoint kan. Sebab tak boleh cakap bising.
Letakkan buku di tempat yang sesak dan sempit bersama datang dan pulang dari sekolah.
Jadi maksudnya
Dia sebab tak cukup space.
tapi bila bagi soalan saya dah nampak maksudnya kita nampak cek budak.
COVID-19 kita mesti
Okey.
kita jadi
Banyak pula dia punya announcement.
happy everybody.
Okay, so kita tengok formative practice 1.3, 23, page 23. Okay, number 1, state the meaning of force in equilibrium. So what is force in equilibrium? We have another 5 minutes, belum habis lagi. So what is force in equilibrium? Can somebody answer me? Nadia, Natasha. What is Nadia, Natasha? You can either switch on your speaker or you can answer in the chat area.
An object is said to be in equilibrium of forces when the forces acting on it produce a zero resultant force.
Yes, okay. So when it produce the forces exerted on an object produce zero resultant force. Okay. So let's look at number 2. Macam mana saya nak suruh you all jawab nak lukis kat sini? Figure 1.31 show a block that is stationary on an inclined plane when a stopping force P is applied horizontally. Sketch and label the weight of the block W and normal reaction from the surface of the plane R. So macam mana saya nak suruh awak lukis? Since saya tak boleh suruh awak lukis kat sini, saya lukislah. But I will give you homework. Yang homework hari tu pun tak siap lagi. So ni ada satu lagi homework yang baru. Okay, so this is the questions for the homework. So hopefully for those who haven't passed out the first homework, the second exercise, actually kita dah ada 2 exercise ya. So the second exercise belum buat lagi, belum buat. And I give ample time for you to answer, for you to do your exercise. Okay, saya bagi seminggu tau. So seminggu tu cukup masa. Dan tapi bila awak tak buat, dia akan jadi banyak and then you are going to give up. Okay, so let's look at formative practice 1.3. Sketch and label the weight. We know the weight will act to which direction? Kavitra, which direction is the weight?
Downwards je.
Okay, downward, perpendicular to the table below.
Yeah.
Okay, and then the normal reaction, Kalpana. Normal reaction? Upward, where? How do we say?
Perpendicular to the inclined plane.
Yes, okay. So R is perpendicular to the inclined plane upward. Okay, so now we have 3 forces on the box. And B, sketch the triangle of force P, W, and R. So what we need to do is we need to label. So we know where is Y, where is W, and where is R, and where is P. And the second part is we need to gerak-gerakkan all these forces, so it will form a triangle, and the direction for the triangle is in a cycle. So kita ambil W and then we ambil P. Perpendicular ni senang kan sebab sekejap. W dengan P ni perpendicular. Okay. So this is R. R, W, P. Okay. Atau awak nak ubah cara lukis yang lain, boleh juga. W, P. Tak boleh. Ini tak boleh sebab dia tak cycle. So W, P. Boleh juga. Okay, so there is no one method. There is no one drawing. Boleh drawing macam-macam ikut cara awak, but the direction of the forces mesti cycle, dan juga bila kita pindahkan dia mesti parallel. Dia tak boleh lari. Okay, because P horizontal, W vertical kan. So kena follow lah. And then R is at a certain angle. Okay, so itu sahaja. Okay, so the exercise for the homework, I will give the third exercise in the Google Classroom. And the due date for this exercise would be after Chinese New Year. Okay, so please complete your exercise 1 for those who haven't pass up. Ada lagi yang belum hantar, ramai. Okay, and then the second exercise in the Google Classroom, baru 2 orang dari 5E, baru 2 orang dari 5M. And then the latest homework, exercise 3. Okay, so the due date for this one would be after Chinese New Year. Okay, so we stop here. Any question before we stop?
The equilibrium from triangle, right? As long as the direction is in a circle, no matter how we draw it, the
Yes.
triangle is correct.
Yes. But you need to make sure dia parallel tau. Dia tak lari dia punya direction. Tapi dia punya mesti dalam cycle lah. Okay, any more? Okay, kalau tak ada, we stop here. Okay, thank you class.
Thank you, Teacher.
Okay.
Teacher.